So, right now, somewhere out there, an artificial intelligence model is combing through like millions of lines of code inside your company's servers.
Yeah.
And it is specifically looking for this tiny, obscure mistake that a human developer made way back in, I think, 2011.
Yep. 2011.
Right. And the terrifying part is it's actually finding them.
It really is.
So, welcome to the deep dive. Our mission today is to kind of cut through the noise of the daily threat landscape by examining 3 critical security briefings for you.
Exactly.
We're going to give you a really concise, practical understanding of how modern networks are being compromised today. Because what we're seeing right now is it's essentially a coordinated assault from 3 totally distinct vectors.
Oh, absolutely. It's coming from everywhere.
Right. We have AI tearing apart this foundational architecture that has literally held up the internet for over a decade. We have threat actors weaponizing web vulnerabilities within like hours of their discovery.
Yeah, the speed is incredible.
And then on top of all that, we have automated platforms that are using our own legitimate authentication features as a weapon against us.
It is a really fascinating and honestly complex time to be defending a network.
I can imagine.
In a world of just absolute information overload,
Yeah.
simply knowing that these attacks exist, it's just no longer enough to protect your infrastructure.
Right. You can't just read the headline.
Exactly. The only way to effectively defend against these threats is to really understand their mechanisms. We have to look under the hood and figure out the why and the how behind the compromise.
Well, let's start by looking under the hood of the Linux kernel, actually, because our first briefing covers a vulnerability that's been dubbed ghost lock.
Yeah, ghost lock.
And this flaw has been hiding in essentially every mainstream Linux distribution since 2011.
Which is an absolute eternity in software.
Seriously. And it allows any logged-in user to gain full root control of a machine, escape containerized environments, and it boasts something like a 97% reliability rate.
But it's practically guaranteed to work.
Researchers at Nebula Security actually walked away with a $92,000 bounty from Google's kernel CPF just for finding this.
And well-deserved, honestly. Because like you said, 15 years in the Linux kernel is an eternity.
Yeah.
So to understand the severity of ghost lock, we really have to look at the mechanism. Technically, it's what we call a use after free bug.
Okay, a use after free.
Right. And it originates in a very old, very heavily utilized piece of kernel machinery called Futex priority inheritance.
Futex priority inheritance. Got it.
Yeah, so basically the kernel has this complex system designed to manage tasks. It specifically tries to ensure that an urgent, high-priority task doesn't get stuck waiting behind some trivial, low-priority one.
Right, that makes logical sense. An operating system needs to be efficient, so it has to, reclaim memory when a process no longer needs it.
Exactly. And under normal circumstances, it is incredibly efficient. But GhostLock exploits a very specific rare edge case.
Yep.
If a lock operation hits a dead end and is forced to kind of back out of its process, the cleanup routine executes at the exact wrong moment in the sequence.
Oh, wow.
Yeah, and because of that timing error, the routine wipes the record of the wrong task entirely.
Okay, let's try to visualize this for a second, because the concept of a use after free bug can get pretty abstract for people.
Sure, yeah, analogies help here.
Let's compare the kernel to a massive storage locker facility, right? The operating system is the manager.
Okay.
So a customer vacates locker number 42, so the manager clears it out and updates their clipboard to say locker 42 is free.
Right.
But because of this timing glitch, the manager gets confused and accidentally hands the master key for locker 42 to a malicious actor.
Yep.
The malicious actor goes in, sets up a command center, puts their own malicious blueprints inside, but the manager still trusts whatever's in locker 42 because they completely forgot they gave it away.
That analogy actually perfectly captures the architectural failure.
Oh, good.
Yeah, the kernel is holding what we call a stale pointer. It's a reference to a scrap of memory it has already discarded and reallocated.
Right.
But it blindly trusts the instructions that are now residing in that memory space.
Mm-hmm.
So by manipulating what gets placed into that newly freed memory, the Nebula team successfully tricked the kernel into executing their own code, but with the ultimate authority of the root user.
That's terrifying.
And in their testing environment, this entire process of triggering the glitch and escalating privileges took about 5 seconds.
Wait, 5 seconds. 5 seconds to completely compromise the foundation of the server.
Yep.
Just 5 seconds.
But I want to push back on the discovery timeline here for a minute.
Okay, go for it.
If this specific code governing priority inheritance has been sitting in the open source Linux kernel since 2011,
Right.
How did thousands of security researchers and automated fuzzing tools miss it for over a decade? I mean, we've had automated vulnerability scanners for years. Honestly, that is the most alarming part of this entire briefing. Traditional fuzzing tools, they work by throwing massive amounts of random data at a program just to see what makes it crash.
Right, like throwing spaghetti at the wall.
Exactly. But Ghost Lock requires a highly specific, complex sequence of lock operations backing out, combined with this incredibly precise timing window for the cleanup routine.
So it's not just random.
No, the mathematical state space required to trigger it is just far too complex for random brute forcing. Nebula didn't find this with traditional fuzzing. They used an AI-driven bug hunting tool called VGA.
Oh, wow.
Yeah, the AI isn't just throwing random data, it's actively mapping execution paths and recognizing logical vulnerabilities that human reviewers and traditional scanners just simply cannot perceive.
So the AI is mapping the logic flow and actively hunting for architectural paradoxes.
Exactly.
And Ghostlock isn't an isolated incident, right? The briefing mentions this is part of a broader trend of AI discovering privilege escalation bugs lately.
We're seeing an absolute wave of them in 2026. Just days before Ghostlock, researchers disclosed a close cousin called Bad EPOL.
Bad EPOL, right.
Yeah, which resides in a similar stretch of kernel code and also grants root access. And another AI model, Anthropic's Mythos, was credited with uncovering related flaws in the exact same subsystem.
Wow.
These automated models are combing through foundational code that human engineers assumed was secure simply because it had been heavily used for a decade without any obvious issues.
Now, a local privilege escalation bug still requires the attacker to have a foothold on the machine in the first place, right?
Yes, normally it does.
But Nebula didn't just report a local bug and call it a day. They combined a Ghostlock with a browser vulnerability to create a fully remote attack chain, which they're calling Ion Stack.
Yeah, they demonstrated how a local bug is often just the final puzzle piece in a much larger, more devastating sequence.
Right.
They started with a known flaw in Firefox that allows code execution inside the browser, but normally that's restricted by the browser's security sandbox.
Okay, so you're trapped in the browser.
Exactly.
Yeah.
But by bolting Ghostlock onto that Firefox exploit, they created the seamless chain. They demonstrated this against Firefox on an Android device.
Oh, on a phone.
Yep. A victim taps a single malicious link, the browser exploit grants the initial restricted foothold, and the Ghostlock instantly shatters the sandbox and carries the attacker all the way to full root control.
A single tap to total device compromise. That's wild. For anyone managing cloud servers or CI/CD pipelines or containerized environments, the practical takeaway here isn't just a simple software update, is it? Because the patch management for this seems exceptionally messy.
Oh, it's a complete logistical headache for system administrators right now.
Really?
Yeah, the initial patch designed to fix Ghostlock actually introduced a secondary kernel panic bug.
Wait, the patch broke the system?
Yes, it caused systems to literally crash under certain loads.
Yeah.
So because of that instability, the fix had to be reworked upstream.
Oh.
This means availability of the stable patch has been highly uneven across different Linux distributions. Ubuntu managed to patch its newest release quickly, but several long-term support versions were just left vulnerable or stuck in a testing state for an extended period.
And the briefing outlines a few mitigations, like randomizing the kernel stack offset, but those aren't actual solutions, are they?
No, they're merely hurdles. Randomizing the stack offset or using static user mode helpers, it makes the memory environment less predictable.
Okay.
It forces the attacker to guess where the vital kernel functions are located.
Right.
It's basically like moving the furniture around in a dark room.
Mm-hmm.
It might trip the attacker up, but it doesn't remove them from the house.
That's a great way to put it.
The underlying vulnerability remains. The absolute priority here must be auditing your specific distribution's advisories and ensuring that your multi-tenant machines, where a local foothold is easiest to obtain, are actually running the finalized stable patch.
Right. So Ghostlock is basically a masterclass in stealth. It's a slow burn threat relying on deeply buried code, requiring time and a local foothold to execute.
Exactly.
But not all attackers operate with stealth, right? Some prefer to bypass the quiet approach entirely and just kick the front door off its hinges before the IT team even wakes up.
Yeah, they really do.
So let's shift our focus to the speed of modern exploitation, which is highlighted in our second briefing.
Right. So the Cybersecurity and Infrastructure Security Agency, CISA, recently added several security flaws to their known exploited vulnerabilities catalog.
The KEV list.
Exactly. And this list is reserved for vulnerabilities that are seeing active, real-world exploitation. And the recent additions from Adobe, Joomla, and Langflow, they illustrate a terrifying compression of the timeline between a vulnerability being disclosed and it being weaponized at scale.
Well, let's look at the Adobe Cold Fusion flaw. It's a path traversal vulnerability that leads to arbitrary code execution, and it carries a maximum severity score of 10.0 out of 10.
You don't get worse than a 10.
Right. And path traversal essentially means an attacker can escape the restricted web directory and read or write files directly onto the server's operating system.
Yeah.
But what stands out here isn't just the severity, but the sheer velocity of the attacks.
The reaction time of threat actors has become virtually instantaneous. Researchers noted active exploitation attempts against this cold fusion flaw within hours of the public disclosure.
Hours?
Hours. We saw immediate activity traced back to infrastructure based in India. Basically, the moment the patch notes are published, automated scanning botnets begin sweeping the entire internet, looking for the specific fingerprint of a vulnerable cold fusion server.
So they are literally reverse engineering the patch to create the exploit and then launching it before system administrators have even finished their morning coffee.
Exactly. It's a race you almost can't win manually.
And we are seeing the exact same urgency with the Joomla vulnerabilities. There's a zero-day flaw in the Gymshaper SP page builder extension that also carries a 10.0 severity score.
Yeah, and the mechanism there is an unrestricted file upload flaw. The application fails to properly validate the type of file being submitted.
So anyone can upload anything.
Pretty much, unauthenticated users can package malicious PHP code inside what the server thinks is just a benign file upload.
Oh, okay.
And once that PHP payload is on the server, it executes. And the attacker essentially commands the database to instantly generate a new super user account.
Wow.
They bypass all authentication and just install themselves as the primary administrator of the website.
And we also have a second Joomla flaw being used to deliver persistent web shells, giving attackers long-term backdoor access. So site managers are urged to update SP Page Builder and Page Builder CK immediately.
Right away, yeah.
But I want to focus deeply on the fourth addition to the CISA catalog because this one represents a pretty massive shift in the underground economy. We're talking about the Langflow vulnerability.
Langflow is a visual framework used for building and testing large language models and AI applications. The vulnerability here is categorized as an insecure direct object reference, or an IDOR.
Right, and for you listening, an IDOR is essentially an authorization failure at the API level. The application verifies who you are, but it forgets to check if you actually have permission to view or edit the specific object you're requesting.
Exactly.
So if I change the flow ID number in my web request from my project to your project, the server just assumes I'm allowed to be there and hands me your data.
That is the precise mechanism, yeah. Is a cross-tenant exposure. The attacker logs in with a basic unprivileged account, manipulates the flow ID in their HTTP request, and suddenly they are executing commands inside another user's AI workspace.
Unbelievable.
But what makes this campaign so noteworthy is the objective. A lone operator weaponized this IDOR flaw, along with a separate remote code execution vulnerability, to systematically steal AWS cloud keys and LLM provider API keys.
Wait, if they have remote code execution on a server, the traditional playbook is to deploy ransomware or quietly exfiltrate customer databases?
Right, the usual stuff.
Why is a threat actor prioritizing the theft of large language model API keys? Are AI credentials like the new high-value currency on the dark web or something?
They absolutely are, because AI compute resources are astronomically expensive.
Oh, that makes sense.
Yet training or running intensive inference on models from OpenAI or Anthropic or proprietary corporate models requires massive GPU overhead. What we are witnessing is basically the evolution of the cryptojacking business model.
Interesting.
Think about it. 5 years ago, an attacker would compromise a server to quietly mine cryptocurrency using your electricity.
Right.
Today, they are hijacking your infrastructure to run their own intensive AI models using your corporate credit card. Or they're just selling proxy access to your LLM keys to other cybercriminals.
Oh, wow. So they are monetizing the AI boom by stealing the raw materials required to participate in it.
Precisely.
And they are using the victim's infrastructure to fetch second-stage downloaders and establish persistent botnets to maintain that access.
Exactly.
For federal agencies, I know CISA mandates a strict 21-day timeline to patch these specific vulnerabilities. But realistically, given the hours-long exploitation window we saw with Cold Fusion, it means a 21 21-day deadline is a luxury no one actually has.
Yeah, if you are waiting for a mandated deadline to apply a critical patch for a public-facing web server, you have already lost the race.
You're done.
The automation leveraged by threat actors means that vulnerability management has to be measured in hours now, not weeks.
So we have examined deeply buried architectural flaws requiring complex execution, and we've analyzed the lightning-fast exploitation of missing patches on web servers.
Right.
Both of these threat models rely on broken code. But what if the code isn't broken?
Yeah, this is where it gets scary.
What if the software is functioning exactly as the developers intended and the attacker simply weaponizes the underlying logic of the system itself?
That introduces our final briefing, and it really represents perhaps the most insidious threat vector we face today. It relies entirely on deception and the abuse of intended features, which pretty much renders traditional patching completely useless.
Right. We are looking at a massive campaign orchestrated by a tooling platform called Deboo. And this operation targets Microsoft 365 environments, and it completely bypasses multi-factor authentication.
Completely bypasses it.
But they aren't achieving this by exploiting a zero-day vulnerability in Microsoft servers. They are abusing a legitimate feature known as the OAuth 2.0 device authorization grant flow.
Yeah. And to understand the brilliance and the danger of this attack, we have to look at how OAuth 2.0 handles device authentication at the API level.
Okay, lay it out for us.
So the device authorization grant is a protocol designed for devices that lack a traditional web browser or keyboard. Think smart TVs, right?
Oh, right, like when you log into an app on your TV.
Exactly. When a device requests access, the authorization server provides a short user code and a verification URL. The user is expected to go to that URL on a separate, secure device like their phone, log in, and enter the code to authorize the TV.
This is basically the vampire rule of cybersecurity, right?
What do you mean?
They can't break in unless you invite them. But by using Microsoft's real device code flow, they trick you into sending the formal invitation, so the MFA bouncer just steps aside and lets them in.
Huh, exactly.
Yeah.
That's a great way to think about it. The attackers behind the Debut campaign are essentially weaponizing that convenience.
Right.
They send targeted phishing emails,
Right.
usually masquerading as urgent payment invoices or shared collaboration folders, basically tricking the victim into clicking a link.
Okay.
But instead of taking the victim to a fake login page designed to steal their password like old phishing attacks did, the link takes them to an attacker-controlled orchestrator domain.
Ah, an orchestrator.
Yeah. In this case, researchers identified compromised Croatian rental websites serving as the orchestrator.
Okay, so I click the link, I go to this Croatian rental site, then what?
Once the victim hits that orchestrator site, the attacker's back-end infrastructure initiates the device authorization grant flow with Microsoft. The orchestrator displays the legitimate Microsoft verification URL and the shortcode to the user.
Okay.
So the user clicks through to the actual genuine Microsoft login portal, they enter their password, they receive their multi-factor authentication prompt on their phone, and because they're actively trying to access what they think is a shared document, they approve the MFA challenge.
And here is where the logic flaw becomes absolutely devastating, because from Microsoft's perspective, everything looks perfect.
Perfectly normal.
The legitimate user entered their correct password and successfully passed the MFA challenge on a known device. But because the attacker's orchestrator initiated the request, the attacker's backend broker is constantly pulling the Microsoft Authentication API in the background.
Exactly.
The millisecond the user approves that MFA prompt, Microsoft generates the session tokens and hands them directly to the attacker's waiting broker.
Yep. The user's location or IP address never factors into the final token generation.
Wow!
The attacker intercepts the OAuth token exchange without ever knowing the user's password. And more importantly, they completely bypass the protection of multi-factor authentication. Once they possess that refresh token, they have persistent, long-term access to the victim's Microsoft 365 environment.
And this isn't just some boutique targeted attack by a small group either. The briefing really emphasizes the industrialization of this technique. Debool is operating as a full-scale phishing-as-a-service platform.
The commercialization of cybercrime is accelerating rapidly. Researchers analyzing the Debool infrastructure found Turkish language developer markers and these highly sophisticated back-end dashboards.
They're running it like a SaaS company.
They really are. And they don't just steal the token. They automate the post-exploitation phase using tools like GraphSpy.
Let's break down GraphSpy because getting the token is only the first step. What actually happens once they are inside the Microsoft 365 tenant?
GraphSpy is a tool designed to interface directly with the Microsoft Graph API. Once the attacker has the OAuth token, They use GraphSpy to silently map out the entire organizational structure.
Oh, man.
Yeah, they can read emails, access SharePoint files, modify inbox rules to hide their tracks, and exfiltrate sensitive data all by making legitimate API calls that blend in perfectly with normal administrative traffic.
So the security team doesn't even see it.
Right. It rarely triggers traditional endpoint detection and response alerts because no malicious malware is ever actually installed on a device.
They are just living entirely off the land, using Microsoft's own administrative tools against the organization.
Exactly.
And Deepool isn't operating in a vacuum. The security firm Cisco Talos recently identified another phishing-as-a-service operator called A-Token, which shares infrastructure with a platform called Evil Tokens.
Yep.
Even legacy phishing kits like Tycoon 2FA are pivoting to this device code technique just to evade law enforcement disruptions.
The barrier to entry for a devastating cyber attack has just plummeted. An affiliate no longer needs to understand the complexities of OAuth 2.0 API polling or token interception.
Right, they don't need to be technical.
Not at all. The phishing-as-a-service platform handles the entire back-end infrastructure, from the orchestrator domains to the graph API exfiltration. All the affiliate has to do is purchase a subscription and send the phishing email.
We have covered an immense amount of ground today, and honestly, when you synthesize these three briefings, the reality of the modern threat landscape becomes starkly apparent. You are defending against a multi-front war.
You really are.
On the foundational level, you have AI models unearthing 15-year-old architectural flaws like GhostLock, forcing you to constantly audit and patch your core infrastructure.
Right.
On the perimeter, you are facing a barrage of automated bots weaponizing public-facing web vulnerabilities within hours of disclosure, and they're treating your enterprise AI keys with the same urgency as financial data.
Yeah, absolutely.
And on the human layer, your employees are being targeted by industrialized phishing-as-a-service platforms that seamlessly bypass your multi-factor authentication by just abusing the legitimate logic of your systems.
It is entirely rational to feel overwhelmed by the sheer volume and sophistication of these threats.
For sure.
But that is exactly why understanding the underlying mechanics is your most effective defense against security fatigue. Whether you are an engineer designing a containerized cloud deployment, an administrator managing web application updates, or simply an employee evaluating a request for an authentication code, recognizing the logical pathways these attacks rely on allows you to anticipate them.
Right.
It shifts your posture from constantly reacting to alerts to proactively understanding how the systems you implicitly trust can actually be manipulated against you.
Because the knowledge of how the machinery works is the only way to recognize when it is being used maliciously. I want to leave you with a final thought to mull over as you look at your own network defenses. We discussed how AI bug hunters like VGA are capable of mapping complex logic flows to find a 15-year-old vulnerability hidden deep inside the Linux kernel.
Right.
What happens when highly industrialized, subscription-based platforms like Deepool start integrating those exact same generative AI models into their phishing workflows?
Oh, that's a scary thought.
What happens when the phishing-as-a-service platform doesn't just automate the token theft, but perfectly mimics the writing style, the conversational cadence, and the strategic timing of your boss when asking you to click that device code link?
Yeah, that changes everything.
The tools of unprecedented discovery and the tools of flawless deception are on a collision course, and that impact will redefine how we establish trust in a digital environment.
Navigating that convergence between automated defense and automated deception will require an entirely new paradigm of critical thinking from all of us.
Thank you for joining us for this deep dive into the architecture of modern threats. Stay curious, question the logic of your systems, and we will see you next time.